What is up, everyone? Welcome to a new video. Today we are going to talk about the conservation of momentum, and I'm going to quickly explain this. So we have two masses with their velocity vectors given before the collision and after the collision, and yes, this is the collision picture. So the thing is, we are taking this as a whole system. In this system there's no other external forces other than these two forces. Okay, so in this system, let's see if the conservation of momentum is true. So the conservation of momentum says that the total momentum before the collision and the total momentum after the collision should be equal. I think you can write that mathematically, right? So yeah, write that mathematically, and let's see if we can prove that. All right. Okay, let's see how to prove that statement. So let's see. So there's essentially a momentum transformation going on, right? So like the momentum changes for these two stuff. One could be going at a higher velocity after the collision, or any vice versa, or something like that. So we don't know that clearly, but we know that when the collision occurs, there's this object puts a force on this object, and this object, mass A, puts a force on mass B, right? So these forces are given. Now, one thing about this is using Newton's third law. So this is Newton's third law. And yeah, so equal and opposite, these forces are equal, and they are equal and opposite. Okay, that is cool. So so conventionally I believe this side to the right it is positive, and to the left it is negative. All right, so this force AB is gonna be negative. So yeah, that's that. So essentially the change in their momentum, like before the collision their momentum is constant, they are not changing their momentum, but when they collide their momentum is essentially changing, right? Because look, their velocity changed over there, so their momentum is definitely changing, so there's definitely a force acting. So these are the two forces, so momentum transformation should be happening. Now, a reminder, if you don't know, force is equal to ma. Yeah, I think most of you all know it, but you can also derive from this is that force is equal to change in momentum divided by change in time. So we can relate momentum and time here. So if you don't know momentum, it is equal to mv. All right, so it is change in this momentum and change in time. All right, so we are dealing with momentum, and that's a good thing. With forces there is momentum within the forces, so something momentum is going on here, some change in momentum, and yes, so maybe conservation could be happening there. All right, so we know that force BA is equal to force AB. Now in most of the derivations it's like minus force AB, but I don't like writing that, because I will write force AB is equal to minus MA, minus MA, and A is of course A here. Oh, by the way, you can put numbers here. I like writing letters down there. I think it's called subscript. Anyhow, that's equal to minus MAA. So what is force BA? Force BA is equal to MB, and that is that is AB. All right, so that is MB AB. So why am I writing like that? All right, so that is MAB is equal to minus MAAA. Okay, so now you might be thinking like this. Oh, okay, why is there a minus sign? Doesn't it look weird? Why is there a minus sign? All right, so this minus sign is actually genius. Now, why is that? Imagine, so you need a positive, right? If this is positive, this value is positive, that means a should be negative here, right? Why? Because we are dealing with opposite and equal and opposite forces, right? So one is going to be the opposite of it, and so that acceleration is going to be negative. You see, acceleration is to the force, right? Where's the force, like where's the force going, like the direction of the force is going, right, to this direction. So a here is inside of the value, there's going to be negative value. Okay, so a is a vector, right? So therefore there's going to be negative. Then if there's a negative, and finally we calculate this negative and negative is going to cancel, and we are going to get positive. Now imagine a is positive. Imagine in this case like force AB is to this direction, and this force BA to this direction, and force BA will be negative, right? If this is positive, this becomes negative. So this minus sign is actually genius. So I had this doubt, now I know how that works. So this having a minus sign over there is good. And yes, if you multiply this entire equation with minus, here there's minus and this getting cancelled, yes, same thing happens. So in all scenarios, this way works very well. So minus is required. Okay, so we know this formula, F is equal to change in momentum by change in time, because we are dealing with momentum, right, in our equation that we need to prove. So in that case, we will look at that. MB is let's take A, because A is equal to V minus U by T. So that is VB minus UB by the same time. That's equal to minus MA, and that is same VA minus VB. Sorry, it's not B. Sorry. So it's VA. So why am I writing VA? This is getting out of hand. Okay. Alright, so that is same change in time. See, in Newton's third law, how these forces are going to be there for the same exact time. So I can definitely cut these times, because if I take this t over there, this is going to divide, and if you multiply this entire equation by this change in time, you can cut it, right? So now let's distribute all of these. Alright, these masses. So you will get mass MB VB minus MB UB is equal to minus MA VA. Now minus plus MA UA. Alright, we are getting somewhere. Alright. Okay, so we are talking about before the collision. Before collision is equal to after collision, right? Alright, so if we are looking that, so this is before collision stuff. Let's take okay, so we are looking that, right? Let's take this. Wait, let me just show you this. So let's take this V here, so I don't need to deal with many stuff. Okay, VB plus MA VA is equal to taking this over here. You know how that works, right? Algebra. So MA UA is plus MB UB. Alright, now these are equal, so same stuff, but if you're willing to, let's just write that. MA UA plus MB UB is equal to MA VA plus MA. I'm sorry, this sounds MB. Okay, so MB VB. So yeah, we found conservation of momentum is true and it's correct. So what did we do? All right, so we know that there's a change in momentum and we are dealing with momentum. So if there's a conservation of momentum, that must be happening in the collision time, right? So in the collision time, the conservation of momentum in these two should be equal. So this force gives the same amount of momentum to this object gives the same amount of momentum over there, and we know that this minus works very well. So in many cases where this situation could be pretty different, this is one of the cases you can find it by just putting the values into it. So that's all for conservation of momentum. It's a really good tool to solve problems, and that's it for this video. Thanks for watching.